An iterator is an object, and like any object, an iterator has to have a data type. The convention for the standard containers, vector, list, set, and so on, is that the data type of the iterator is the word iterator prefixed with the member of operator and the class that this iterator belongs to. Iterator as a concept works for any kind of container, but an iterator that works for a vector and an iterator that works for a set and an iterator that works for a list are going to be internally different, and consequently you need to say for your iterator type which container class that iterator belongs to. So we read this by saying that the data type for an iterator is iterator that is a member of some container class. And I see that my notation here says read from right to left. Well, of course, that should be read from left to right in the usual way, so I'm sorry for that typo. Here on slide 7, for a given particular container object, obj, we show how to get an iterator for the beginning of that container, that is, an iterator, quote, pointing to, unquote, the initial element. You do that either by saying the container name and then dot begin, or, since C++11, you can use begin as a function name with the object as an argument. They will both produce the same result. Now, the iterator marking the end of the container is either container object.end, or, again, since C++11, you can use end as a function name with the object name as an argument. Now, end, as we've seen in some examples, does not give you a, quote, pointer to, unquote, the last element. What it does is it gives you a pointer that's one past the final element in the array. So you cannot access the element of a container at the end, but you can access all of the elements of the container up to but not including the end. Now, real pointers to successive memory locations are in ascending address order, but iterators are a generalized idea of pointers. They are not ordered in an ascending order the way real pointers are. So you cannot, in general, use the less than symbol to compare one iterator to another. In fact, it may not be the case that the begin iterator for a particular container has a value in some sense less than the end iterator. You can only use the equality test, double equal sign, and the inequality test, exclamation mark equal, to determine whether two iterators are equal to each other or are not equal to each other. Here on slide 8, we've got an illustration of this. We've seen this kind of thing in examples before, so this is really a review. We're showing two different ways of looping through the elements of a vector of int, either using an actual pointer to int, which we can do with a vector because the elements are in ascending contiguous memory locations, or using an iterator whose data type is iterator belonging to the vector of int class. So, in the black code here, we're finding the end of the vector, which, recall, is actually one past the last element of the vector, by getting the address of the sub-zero element of IV4 and then adding the size of the vector. So IV4, recall, from slide 3 has 6 elements in it. Therefore, the address of IV4 sub-0 plus 6 will be a pointer to the int that is one past the last element of IV4. That is, a pointer to an int that is one past the 7, which is the last element value. And in our for loop here on slide 8, we're using a pointer object, P, to step through and point at the successive elements of IV4. So P is initialized to the address of IV4 sub 0. Then, as long as P is not the end, that is, as long as P is still pointing within the bounds of the vector, we're going to display star P, that is the value that P is currently pointing to, and when that's done, we're going to increment the pointer to point to the next slot. So as we've seen many times, this is going to step through the elements of this vector as though the vector were an array, printing out 1, 2, 3, 9, 8, 7, and then when the loop is over, we display a new line character. Our loop using iterators in red is structured in exactly the same way, but in this case, IT has type iterator of the vector of int class. We initialize IT to IV4.begin, and then as long as IT is not equal to IV4.end, we display the value that IT is, quote, pointing to, unquote, namely star IT, and we increment IT. So again, we've seen this kind of example in the past, but we have glossed over what the actual data type of this iterator IT is. If we're using an iterator to step through a vector of int, then we need to declare IT to be an iterator that is a member of the vector of int class. Now, so IT's actual data type is iterator that is a member of the vector of int class, but nobody wants to type all that mess. Who wants to type vector, angle bracket, int, close bracket, colon, colon, iterator? In C++11, as we talked about before, you can use the auto keyword instead as the type of an object, and the compiler will figure out from context what the actual data type of the object should be. And so if I use auto in my declaration of IT, then since IV4 is a vector of int, and IV4.begin produces an object whose data type is iterator that is a member of the vector of int class, we can use auto to just let the compiler figure that out for us. Okay. So here on slide 10, we are using iterators on the vector of int IV4 not merely as a means of stepping through the elements in the vector IV4, but as a way of marking places where we want to insert or erase values within this vector IV4. Okay, so as a reminder, what IV4 originally contains, which is what is being displayed here in this for loop on the bottom of slide 9, is 1, 2, 3, 9, 8, 7. The vector class offers an insert member function that takes an iterator to some place within the vector as its first argument, and a value that you want to have inserted ahead of where that iterator is pointing to. So IV4.begin is, quote, pointing to, unquote, the initial element of IV4. And so this statement here, IV4.insert, IV4.begin, comma, -4, is going to insert the -4 ahead of the beginning element of IV4. So we end up having inserted -4 ahead of the 1 in the vector. Here I'm using auto to declare IT as an iterator that is a member of the vector of int class. Specifically, this is an iterator, quote, pointing to, unquote, the initial element of IV4, which at this point is -4. If I increment my iterator 2 times, plus plus IT twice, and I use the erase member function, the erase member function can be called with an iterator indicating which element you want to erase. Now, initially this iterator was pointing at -4. I've incremented it twice so that it's pointing at the 2. And when I erase the element that that iterator is pointing to, the 2 is now taken out of the vector, and so my vector has -4, 1, 3, 9, 8, 7.